Good morning, everyone. Good morning, everyone. I am Senthil, head of the Department of Mathematics in Arignar College, Krishnagiri. I am here to present a talk on metric space in real analysis, which plays a key role in modern mathematics. Metric space definition metric. Let X be a non-empty set. Define D is a function from x cross x to R. Then D is said to be a metric on X if it satisfies the following conditions: non-negativity, D of x comma y greater than or equal to 0 for all x comma y belongs to X. Definiteness, D of x comma y equal to 0 if and only if x equal to y. Symmetry, D of x comma y equal to D of y comma x. Triangle inequality, D of x comma y less than or equal to D of x comma z plus D of z comma y for all x comma y z belongs to capital X. Definition, metric space. A non-empty set X along with metric D on X is called a metric space. It is denoted by x comma d or simply x. Example, let x equal to r. Define d from r to r by d of x comma y equal to modulus x minus y for all x comma y belongs to capital R. To check d is a metric on R. Non-negativity, d of x comma y equal to modulus x minus y. We know that the absolute value is greater than or equal to 0. Definiteness, d of x comma y equal to 0, which means that modulus x minus y equal to 0, which means that x minus y equal to 0, which implies x equal to y. Symmetry, d of x comma y equal to modulus x minus y equal to, we take minus outside in the absolute value equal to modulus of y minus x equal to modulus y minus x equal to d of y comma x. Triangle inequality, consider d of x comma y equal to modulus x minus y equal to, we had plus z and minus z. So we have modulus x minus z plus z minus y equal to x minus z minus of y minus z equal to modulus x minus z plus z minus y. Properties of modulus, we get less than or equal to modulus x minus z plus modulus z minus y, which implies d of x comma z plus d of z comma y for all x comma y comma z belongs to R. Since d satisfies all the axioms of the metric, hence D is the metric on R called usual metric or standard metric. Definition, neighborhood of a point. Let x comma d be a metric space. Let P belongs to X. Then a neighborhood of a point P is a set n r of P defined as n r of P equal to the set of all x belongs to capital X such that d of x comma y is less than r. The number r which is greater than 0 is called radius of n r of P. Definition, interior point. Let x comma d be a metric space. Let E is a subset of X. Let us take P belongs to capital E. Then P is said to be an interior point of E if there exists a neighborhood n r of P such that n r of P which is contained in capital E. Example, we can take x equal to r and E equal to z. We know z is set of all integers. Set of all integers is contained in R. We know that neighborhood of x equal to x minus epsilon comma x plus epsilon open interval. For epsilon equal to 2, The neighborhood of minus 1, we know minus 3 comma 1, but minus 3 comma 1 does not contain in z. That is, we cannot find any neighborhood of any integer which is contained in z. Therefore, z has no interior points. Example of interior point. Let e equal to 2 comma 6 contained in R. All reals between 2 and 6 are interior points. Definition: open set. Let x comma d be a metric space. Let E is a subset of X. Then E is said to be an open set if every point of E is an interior point. Example of open set. Let x equal to R with usual metric. Let E equal to the open interval minus 1 comma 5. Points of E equal to all reals between minus 1 and 5. Interior point of E equal to all reals between minus 1 and 5. Therefore, E is open. In general, every open interval is open. Thank you.